Hey everybody, how's it going? Welcome back to my basement. New thing going on here. I was doing some work on that actually. It's over here, the Spider-Man 2099 suit. Just didn't want to get super full of 3D printing scraps. Besides the point, we'll talk about that in a whole other video. But today I'm doing a video on a request that came in asking me how I tuned this guy. And I'll take you through the steps I did. All of this can be done through Orca Slicer though, so if you don't have that already, that's what I used. If you go ahead and install Orca Slicer, you can go on to printables.com and get the K1 Max and the K1 profile for Orca, which is the one that I'll be using in my video. But it's a pretty simple process. What we're going to do is we're going to go to Calibration up at the top, and we're going to select literally from all of those drop-down options. The ones that I don't do, I believe, are either the last two or the last three. I can't remember exactly. I believe it's the last two. But the ones that I did do for my printer specifically are the flow calibrations, the temperature tower. Can't talk. As well as the retraction test, and what other one am I missing? I think that's it actually. I think it's just those three tests, but one of them split into two parts. So I'm actually going to do that here on my laptop right here so you guys can then see it. And once I get this first one going, I will be right back. All right, everybody. So here's what we're going to do. So here's the calibration tab that I was talking about. And you have your temperature, your flow rate, pressure advance, which I forgot about, and your retraction, and then the Orca tolerance test. There are more tests, which are the max flow rate and the VFA. I actually don't do these. There are a couple of videos that have more detail on how these work and what to do. I haven't done it myself, so I'm not going to try to sit here and figure it out with you. But if you want to see those videos, please just look it up. I'm pretty sure you can find them all over YouTube. A lot of people are actually going through all of these things as well. But for my video, I'm going to stick to temperature, flow rate, pressure advance, retraction test, and then finally the Orca tolerance test, which is just to make sure that you've done everything that you can to get this as perfect as possible. So the first thing I like to do is run a temperature tower. But first, let me set all of my stuff back over to default here. So we're going to go back in here, make sure everything here is set back to default. Nothing has been changed. Pressure advance is still at 0.2. Default printing temperatures. I think these actually are changed, but that's fine. This is essentially the range that I'm going to be in anyways. Please do run that temperature tower. I'm not going to run it in this video just because I already know that for me, my temperature here is right around 218, 220 for printing PLA. But I recommend you do this on every single type of filament that you're going to do. But just to show you what I do for mine, we're going to go to calibration, temperature, PLA. You have PETG, carbon fiber, PTCF, TPU, ABS, ASA, all the main ones that you're going to use. And here's your temperature ranges. You can change them to whatever you would like. This is the default 190 to 230. So let's go ahead and load that in. Here it is. So I'm going to go ahead and print this. This is going to be the first of our tests, and I will catch you guys here shortly. Hey everybody, new day. The temperature tower finally finished. It's right here, in here. I don't know if you can see it. I'll add a close up here later. But here it is on the build plate. I'll add something in as well. So you want to check for a few things on this guy. So there's a few things you want to check for. You want to make sure that me see if I can get close here. Try to be quiet-ish. You want to pay attention to the little triangles. Like, yeah, there it is. Little triangles or little points here. You want to look for one that looks nice and doesn't have as much stringing. So that's the first thing. The next thing you want to look at is the bridging. I don't know if you guys can see the bridging that happens here because there's no supports. And you want to see which one is roughly the best. So for example, for mine, I'm sitting right around 215 to 220. It looks really nice. And then you also want to take a look at the sides here to see how that did. And you could also use the back of them as reference as well. Those are the things that I look into when doing something like this. So running these tests, I check these things. So for me here, between 215 to 220 is around the sweet spot. And then we'll run all the other tests here in a second so you can see what I'm talking about. So next will be the flow. Apologies for the sounds upstairs. My son is playing upstairs. But yeah, so we'll do the flow rate next now that we have our temperature. All right, everybody. So now we're going to move on to the flow rate. Apologies if you can hear that upstairs. Is my son playing with my wife. But yeah, so now flow rate. There's 2 passes, so we're obviously going to start with 1. We're going to transfer, and we're going to do what we learned from our print as to which one was the best temperature. So you can see here, these are the defaults, 230. So we're going to go back down. Let's bump this up to 218 here. So the reason you want to print your first layer higher is so that you have better adhesion. And then you want to move to the next layer, to the other layers at the temperature that prints the best. So let's save that, hit OK. Cool. So this next flow rate area is going to have to do with this section here. So this will either go up or it'll go down based on whatever we select here in a second. Once the stuff is printed out. So let's go ahead and close that. Slice the plate. And let's go ahead and print this guy. Upload and print. All right. Catch you guys here in a second. All right, and we're back. So it finished. Here it is. The flow rate test, the first one. So I'm going to get my ugly mug here out of the way. So, oh man, this bright. Let's turn this down a little bit so you guys can see what I'm talking about. All right, so you see how this is 0? This is where it's at by default. So there's no changes to it. This is +5. This is, oh no, sorry, this is -5. This is +5. It's kind of hard to see. But it goes all the way up to these high numbers and then down below to the low portions of it. So what you want to do is you want to run your finger over it and see which one feels the nicest. So to me, this one feels a little rough, but it feels nice. This one feels good, but it feels like there's some gaps in between. This one feels really gappy. +10. +10 feels real nice up until here. It gets really coarse. But the middle feels kind of nice. So then the next thing you want to do is really inspect it yourself. Just actually like look. I like to like, with the light on, maneuver it just a little bit. Let me turn this back up. Sorry. It's too white. Too light. That's better. So I like to like maneuver it and see it in the light. See if I can see any gaps in between the layers, the top layers. And just kind of like look at it, see how it looks. Obviously you know that +20 and -20 are not it for me. They might be for you. This is all dependent on your machine, your specific situation, the environment that you print in, all of that. That all takes into account what your results are. So don't try to mimic mine and expect your results to look exactly like mine, because your mimic results to me might look like if I went up to 20 and decided to stay there. Like, it's different for everybody. But for me, I like 5. 5 feels nice. There doesn't seem to be any gaps in between the layers like there are with 0. 10 looks nice too, but I feel like 10 might be a little too bumpy. 5 feels flatter. So we're going to go with 5. And then once we move over here, I can show you the math and formula for that as well, and which you can also pull up on your computer on Orca Slicer. So let's go ahead and move over to there. Hey everybody. All right, so back in Orca. So here is this. I should have mentioned this in the beginning. This is very important, the tutorial. If you click that, it'll actually open up a web page. Let's actually close all of this stuff. That explains everything that you're doing. Everything that I'm doing here is all explained in this documentation as well. And it gives you everything you need to know. So what we just did was the flow rate calibration. So as you can see here, it shows you which one looks better, which one looks smoother, anything like that. Under extrusion, you don't want that. You don't want the gaps. You want it to be nice and well layered. So here's the formula. Actually, this is the one that I'm going to be using. So this is what you start off with, or you plug in whatever you're at currently. If it's default, this is exactly what it should be. And then you plug in the formula. So I actually did go with the +5. So this is my result here. So I'm actually going to enter that. So just copy that. All right. Let's minimize this guy. And we're going to go into the PLA settings, or into the filament settings. And you're going to find flow rate right here. You're going to plug in your new value. Your new value would be whatever it could be. If it was -5, you'd put in the result for -5 here. I like to keep it as a rule of thumb of only putting 3 digits past the decimal point. So 1.029. If yours was 1.0298888, I'd just do the first 3. Don't worry about the rest of it, because honestly, like it might make a little minor difference in the end. So we're going to save that. So we're going to save that here. Okay. All right. And then we're going to do pass to. So this, just click. I usually always click transfer. Doesn't really matter in the early stages. But now, as you can see here, you're going to get 0, which is what you currently selected. So the +5 is no change. Then you have -1 and then -2, 3, 4, 5. -5 brings you back to where you were. And then obviously you have -6, -9, -8, -7. So if any of these numbers here look better, you might want to redo the test from the beginning, just in case. But I'm hopeful that either 0 will look good and we don't have to do any more change, or -1 or -2 might look a little bit better, and then we go with that. But anyways, let's go ahead and slice this up. And let's go ahead and print it, and then upload and print. All right, catch you guys here in a second. All right, we're back again. I finished the part 2 of the flow calibration. All right, so same thing as before. You want to check for roughness on the surface, smoothness. You want to make sure that there's no gaps in between the layer lines. And overall, which one looks the nicest to you. So here are the ones that I printed here. One feels nice, and you can feel as you go down that you might be able to see it too. There's more gaps in between the layer lines. I don't know if that's going to focus on that, but there's more gaps in between the layer lines. You want to make sure you pick the best one to you. For me, let's see. Kind of like -1 a little bit. That one looks, actually no, that one feels nice. 0 feels nice. -1 feels nice. -2 feels nice. You know what? I'm gonna stick with 0. It seems like 0 for me on this, particularly this red PLA, looks and feels the nicest. So for me, there's nothing else that I need to do. For you, you might have to do the math some more, which I'll do here in a second for you guys. But yeah, for me, it looks like what I have now is perfect. But I'll show you the rest of the math now with the new numbers, and we'll do -1 just so you can see what I'm talking about. Catch you guys over here in a second. All right, guys. So for me, the best number that I had was 0, so there shouldn't be anything else for me to do. But just for the sake of doing the math with you guys, just so you can see it, I'm going to do it here. So you want to take this exact same formula. Let's take it here. Right? Just plug it in here just so you can see. So you want to take the number you have currently. So for me, it is this. And let's open it back up. So we're going to type that in here. And in here, since I liked it at 0, obviously it's not going to change anything. But you would plug in the plus or minus, whatever it is that you liked. In this case, I think you can only do minus, but there's no change for me. For you, it might have been -1, which would give you this 1.018. And whatever it might be, you just want to copy that number, pop it back into here, and save it. Okay. And now you have your flow rate. So we're almost done, guys. So you want to do your pressure advance next. So I like to do it starting at 0 and then doing it until 0.15. So there's a couple things you can do. You can do the line test, which will draw a line and then jerk the head at certain points. That one for me is a little bit harder to read. The one that I'm doing is essentially it's a tower, and then you measure it out with some clippers, and then you do some math, and it gets you a total, which is what we're going to do here. I feel like it's a little bit more accurate. So let's go ahead and load that in. Oh, you also want to, obviously, we're direct drive extruder. We're not Bowden. Hit OK. Just hit transfer. It'll load in the shape. This is the shape here. And we're going to go ahead and slice the plate. And then we're going to go ahead and hit print. Upload and print. Alright guys, I'll catch you back over there in a second. Alright, it finished. It's done. Here it is. Let me pull it out so you can see what I'm talking about. So this guy, that was easy. Put that to the side for a second. Let's get all this stuff off. Let's put this bad boy back in. So this is what you should get, or if you did the lines, you'll see that on the build plate. I prefer this method. In my opinion, it's just a little bit better. So essentially what you're doing is you're sharpening all the corners in your prints, and that's what this guy is for. You want to make sure you choose the sharpest area on all sides of this guy. So for example, you're going to need a pair of calipers. I have digital ones and then I have manual ones here, but you want to find, let me move out of the way, see if this will, the sharpest area. Can't quite make this out on the camera, it looks like. And it's also, why does this show up as orange? It's red. It's the same as the Deadpool mask, it's red. So what you want to do is you want to try to find the sharpest corner you can, or the area where it looks the nicest. For example, here, let's see if I could find it. Seems to be right around like the 10 millimeter mark. Right around the 10 millimeter mark, it looks like. And then you want to, what I do is I find one area where I can see the best, and then I move around from there. So then this next area here, so I like to also look at it from the side. That's not focusing very well. There you go. To see where we're at. So right here I'm currently at 10. This looks pretty good at 10 as well. This side does too. I just check all the sides just to make sure I have a good sample size, if you will. 10 looks to be the best. If you find another area on your print that seems to look a little bit better, probably go with that. You don't want it to be too round. You don't want it to be too pointy. You don't want it to look like this area here at the top. I don't know if you can see that too well, but it's all like under extruded. Looks like a hot mess. But yeah, so you want to find the right one. So for me, it's 10 millimeters all around. I checked it, 10 millimeters. So what you want to do is you want to go back to your computer and go to the tutorial and it'll tell you what to multiply 10 millimeters by, is essentially what you're going to do. So let's go ahead and go over there and do that right now. Alright guys, so here's the section on what to do. So it tells you to print, it tells you to measure it out. As you can see here, it tells you what to do, and then the formula is right here. So 0.002 times whatever measurement you got. So for me it was 10. So for me it would be something a little bit different. So let's do 0.002 times 10. This gives me a 0.02. So that's going to go in here. And mine is actually already at that 0.02. Yours might be 0.024, 0.023, 0.02 something. You just want to put in that number there. So mine's fine, so I don't have to do anything about that. Let's go ahead and save that, hit OK. And now for the final test. So I'll go ahead and do it here. So it's going to be the retraction test. I like to do it all the way up to 3 millimeters. For Bowden setups, that's the maximum amount you want to do. I just like to include that so we can see what it looks like. So you're going to hit OK. Let's go ahead and just transfer everything. Slice the plate. And you'll see here, so you'll actually see it a lot better when it's actually printed, but there's notches that are along this. That's a good road. Each one of them, so here's 0, here's, and then it goes up by increments all the way up to 3. I can't really show you that very well on camera. It won't show up too well, but essentially what you want to do, you want to count these. Each one of them is a step, and you want to see which one has the least amount of stringing. So I'll go ahead and print this guy, and I'll see you guys here in a second. Alright guys, it just finished. Change of outfit. It got really cold down here, so I had to put on a sweater. But so the retraction test is essentially the final test that you're going to do on Orca Slicer, unless you want to move on to the VFA and the other test that's there. You can most definitely do those. I don't personally do those myself because I'm not looking to print at the highest possible speed on my printer, and that's essentially what you're going to do with the last two tests, is just to make your printer faster and probably just look a little bit nicer as well. But let me just pull this out right here. Alright, I don't know if you can see that there, but there it is. There is some stringing towards the top, and then there's some down at the bottom. Don't know if you can actually see some of that, but you want to pick out somewhere in the area where there isn't any. What I like to do is I like to find a nice area where there doesn't seem to be any stringing, and then pick the middle of that. That's generally a good thing to do, is just pick a nice little area, because in some cases you can't really tell on this thing here, but there isn't so much that there's stringing, but there's fuzzies on it, and that's something that I actually did suffer a lot with some of my prints, was a lot of fuzziness. So to eliminate that, you want to find the area where it's the cleanest on both sides. Let's put this guy back. So maybe you might be able to see it better now that I've taken it off of the build plate. So here, trying to get this to focus. So you see the stringiness up at the top, and then the tiny little bit at the bottom there. What you want to do is you want to try to find somewhere here where there isn't any. So in most cases you want to look at also like the fuzziness. I'm going to pull that a little bit just to see where you have some, where you don't have some. You have a lot towards the top, obviously, and you have a lot towards the bottom because it's almost no retraction. So for me it looks like my range is right about here, which would be, let's see, 0, 1, 2, 3, 4, 5. And then we match that on this other side, so 0, 1, 2, 3, 4, 5. And it looks like there's very little stringing there too, but I might want to go down 1. So because this is in, I believe it's 0.1 increments, that's a 0.4 for me. It could go all the way up to 3 for you. That's essentially the maximum. It might even be more than that. So you might find that it's stringy all the way through. Maybe keep going up until you don't find anything, but the higher up you go, the more likely that you're going to have stringing beyond 3. But there's a chance that 3.1, 3.2, 3.3 might work for you. Again, all of this stuff is situational. It depends on your printer. Your settings are not going to be the same as my settings. And your settings might be, you know, in your kitchen, in your living room. I'm in my basement. It's cold down here. Yours might be in a basement or in a garage. I don't know your situation, but run all of these tests. We're about to run the final test, which isn't really a test, as more of a check to make sure you did all of the things correctly. You were as detailed as you could in this, and that everything works out really, really well, so that things, when you print them so that they fit in each other, fit really well, and your tolerances are nice and tight. So I'm going to move over to this computer here, input this last bit of here, and put this last information into the slicer, and then we will print the Orca tolerance test. And if all goes well, we should be able to fit everything in a 0.05 or a 0.1 or a 0.2. But if you want higher than a 0.2 and you can't get past the 0.2, remember to just go back, start from the beginning. You don't really necessarily have to start from scratch. You can take wherever you're from and do the flow rate again, and your temperature tower, and the retraction test, and just get through all of those settings one more time and make sure you're good. If you want my settings, I will be more than happy to post those, but again, those might not work for you, or they might. Who knows? Let's get over here. Alright guys, we're back here in Orca Slicer. So the area where you input your retraction settings is actually going to be in the printer profile. So you want to click the little edit button. You want to go to extruder, and you want to find the retraction length. So here mine is at 0.5. I decided I wanted to do a 0.4 based on my test results, and we're going to save that. Hit OK. Bam. Saved. So I'm actually going to, yeah, that's good right there. All right. So now that we have everything done, let's go to the final thing here, which is the Orca tolerance test. Let's go ahead and just hit transfer. Here it is. So you want to print this without a brim and with no supports, essentially just how it is right here. Let's go ahead and slice it. So my goal for most of my printers is to always have it fit at the 0.05. The 0 is not impossible to do. It's just a little bit difficult, in my opinion, to get to that perfect level, because it takes a lot of factors for this to be as tight as possible. 0.05 for me is perfect. You know, it's more than fine. 0.2 is even very acceptable. It's when you start going beyond 0.2 that it becomes a little difficult, especially if you're printing parts that are meant to go together, or things are supposed to go in your prints. It becomes a little bit more challenging. So what we're aiming for is 0.05. If you get 0.1, that's still great. You know, that's still really good. But if you want to get into the lower digits, you're really going to have to fine tune every little detail about your printer. You're going to have to get into possibly drying your filament. I know some people recommend it with PLA. Some people don't. I have a mixed bag on that. I dry some of my filament. Some of my filament I don't dry because it never needs to be dried, but some of it performs terribly without being dried. Tightening your belts, tensioning all of the things in your printer, that can get you as close to 0 as possible, as also with doing all of these calibrations to a perfection. So let's go ahead and send this off to the printer, and this is essentially, this is it. This is the final part of the test. This will tell you whether you want to redo everything or leave it where it's at. So let's go ahead and send this over to the printer. Hey everybody, new day, and the final thing, the final tolerance test printed. It finished last night. I was just too tired to come down here and record this, but it's here. Let's go ahead and take a look at it. So if you've done everything, the way that I've done it, you should be able to. Oh my goodness. You can do two things. You can either use an Allen wrench or you can use the little key that's printed. It's up to you. So you can use a little key here, this guy. This tiny little piece that prints with it. Or you can use an Allen wrench. It's about, I forget exactly the size, but I know in the actual tutorial paperwork thing that they have in there, it tells you what size it is. So you'll notice that at 4, no problem, no biggie, goes in, comes out, easy. Oops, don't want to drop it now. At 3, same thing, goes in, no problem, comes out, no biggie. At point 2, goes in, comes out, no problem, no biggie. That's pretty good. Point 2 is generally where I like to be at, but it doesn't hurt to be at a lower number. So point 1, see where we're at? Well, this was a little tight. Oh, looks like I'm gonna have to redo everything for myself. So it doesn't really fit in point 1. Now, it could just be the fact that I didn't really super fine tune all of my settings because I already have a profile with it super dialed in. But I did this video more or less to show you the process that I went through. So as you can see here, it doesn't really go in all the way at point 1. The one that my profile that I normally use, it fits in 0.05. So this just to me means if I want it to go lower, I need to go back in with the settings that I currently have and redo all the tests again and try to really fine tune everything. Now, this is it. This is the end of what I personally do. There's more things that you guys can do. There's the 2 extra settings that you can go in through and change everything if you want to make your printer a little bit better when it's printing really fast. It shows you the maximum speed that it can print. It's really useful. I've just never used it because, like I said, I don't intend to max out my printer at its full potential speed. You know, some people love to do that and print really fast benchies. But that's totally up to you. You guys can do whatever you want. At the end of the day, it's your printer. This is just an opinion as to what I do. There are many other things you guys can do as well to improve the print quality of your printer. Like I mentioned earlier, tightening those belts, making sure your print bed is as level as you can get it. I know all the K1 Maxes that I have seen on YouTube videos or that I have seen on the Reddit that I'm in have a really bad level when it comes to the points. There are certain things that you can print to make that better. Like there's little wedges that you can print to go in between the bed mount and the screws so that it kind of tries to level itself out a little bit. But that's all up to you guys if you want to do that. I know I just have to go in every once in a while and tweak the Z offset on my printer and everything usually prints perfectly fine. But yeah, so if you want to get closer to 0, just go back, fine tune those settings, and then you should hopefully eventually be able to get there. If not, 0.05, honestly guys, that's really good for a printer. 0 would be great, but it's not that it's hard to achieve. It just takes a lot of patience and a lot of work and a lot of testing and retesting and doing all of these things over and over again and making sure your printer's good, making sure your filament's dry, all that stuff. So I hope you guys enjoyed the video. It took me a span of a couple of days here to film everything for you guys, but that's just because I film at night. Except for right now, it's daytime. Look at that, the window, it's bright. It's so nice. But yeah, I hope you guys enjoyed the video. Please leave a comment if you want more information. I know I'm definitely going to make a much shorter version of this video, so it's much easier to go through without seeing my face. It'll mostly just be me going through the settings on my computer and uploading that as well. So there'll be a link for that down in the description once I get it done. But until next time, guys, have fun tuning your printers.